Welcome to a tutorial of ProfLearn YouTube channel. In this particular video, we're going to discuss this Unit 3 of IAL Edexcel Practical 1 skills. And we're going to see what are you supposed to do whenever you are asked various questions. So we shall base our discussions on the main aspects, the main concept that you need to know, and the best way possible to approach them. One of the questions that you'll be expected to answer in this Unit 3 paper is the question to do with uncertainty. And you will be given two case scenarios, where a situation whereby you are given a single data and you are supposed to work out uncertainty, percentage uncertainty. And another scenario, you'll be given data values. Maybe you are given a list of data, 2, 3, or 5 values, and then you are supposed to calculate the percentage uncertainty for that case. So we're told here a student investigated how the acceleration of a toy car on a ramp depends on the angle of the ramp, which is well displayed on the screen here. And you can see we are given a toy car at a given point here, and then it's going to move down the slope for it to pass through the light gate. And the light gate can maybe tell us at what speed that toy car will pass the light gate there. And then we are told that the student measured the length L of the toy car using a digital calipers, and the reading is shown here as 75.6 millimeters. And then we are supposed to determine the percentage uncertainty. So something that you need to understand is that percentage uncertainty is calculated from uncertainty divided by the reading or the measurement that has been taken times 100%. But for you to work out the uncertainty in this case, you look at the number of decimal places this instrument is having, which means this is 75.6, so that is written correct to 1 decimal place. So which means the least unit this instrument can measure is 0.1 millimeters, and that becomes our resolution. Once we have the resolution, we can be able to get the uncertainty, and we know that uncertainty is equals to a half of the resolution. So in this case, our uncertainty is going to be a half times 0.1, and that becomes 0.05 as our uncertainty. Then to work out the percentage uncertainty of this measurement, we are going to say 0.05 divided by the measurement, which was 75.6, times 100, and that becomes 0.066%. And something that you need to understand here is that always uncertainty, percentage uncertainty in IAL exam is either given correct to 1 decimal, correct to 1 significant figure, or 2 significant figures, nothing more than that. The student adjusted the ramp so that the angle is 20 degrees. She released the toy car from the top of the ramp and recorded the time from the data logger. She repeated several times as shown in the table. So we have different times, that's in milliseconds. So which means that we are going to work out the mean of these values that we are having here. Remember, mean is the sum of all the data values, then divide by the number of measurements that you are having. Now in this case, we are going to have 23.9 divided by 5, then that translates to 44.8. Something that you need to remember here, you have to ensure that your answer as the mean should be correct to the number of significant figures that was in the raw data. And something also I need to mention here is that if you have an anomalous point, anomalous point is a strange value, maybe that is not in the trend of the values that are there. if you find the value that is an outlier, a value that is so big than the rest, then we are going to consider that as an anomalous point, and then you are not going to consider using it when we are working out the mean, right? The next part is to determine the percentage uncertainty, and something I need to mention here. When you are given a set of values, for you to find the percentage uncertainty, first you must find the range. And the range is the difference between the largest value and the smallest value. And that's once you've gotten the range, now you can go ahead and work out what? The uncertainty. And uncertainty now, when you're given a set of values, becomes a half of the range. Now, once you have the uncertainty as shown here, then we're going to say percentage uncertainty is going to be uncertainty over the mean times 100. So you need to know the difference approach you are going to employ when it comes to working out the percentage uncertainty if you are given a single value and when you are given a set of values. And you can see here you are supposed to work out the mean, find the range, use the range to find and divide it by 2 to get the uncertainty, and then now percentage uncertainty become uncertainty over the mean times 100, and our case here we are going to get our answer correct to two significant figures as 0.78. The next part is describe the method the student could use to determine the acceleration of the car. And the method here is to measure the distance. The student was supposed to measure the distance between the starting point. The student was supposed to measure the distance between the starting point and the light gate. Once the student has measured that distance, that will be our displacement, right? Then we shall also record the speed at which this toy car is going to pass through the light gate, and that will be our final speed. And then we use the subvert equations. We can use v squared equals to u squared, but remember the initial velocity of the toy car, because it's being released from a point where it was at rest, the initial velocity will be 0. And then we can now apply that formula of the subvert equation of motion, which is v squared equals to u squared plus 2as, where a is the acceleration and s is the displacement. So rearrange the formula, we can be able to get acceleration, and acceleration is going to be v squared over 2s as shown there. Looking at question 2, we are told that concrete is often used to make supporting beams in buildings. Strands of materials can be added to the concrete to mix and produce fiber reinforced concrete. A student had some small beam made fiber reinforced concrete. Each beam was the same size. He placed the beam across 2 supports as shown there. And describe the method the student could use to determine the accurate value of maximum force a beam can support. So you see, if we put different masses at the center of this concrete, then we can keep on adding the mass and check how much can this support before cracking or breaking. So if we add a given and we realize there is a given number of mass that makes this to crack, then it means now we can be able to go and work out the weight of the masses that we have added for it to crack. So in that way, we were to say place known mass at the middle of the concrete, keep adding the masses gradually until the beam cracks. Then calculate the maximum force. To calculate the maximum force, we are going to work out the weight using the formula weight equals to mass times gravity. But remember, weight is the force that is going to be cracking this block. Then we can repeat with other beams in order to work out the minimum, rather to work out the mean. so that we to work out the mean, so that we can know the average force that is required for this to break. Identify health safety issues with your method, and you can see here, if a beam cracks or breaks, what's going to, there are some particles which will how can we put it, there are some particles that can go into your eyes, yeah, when it cracks, yeah. And also you can say when it cracks, some of the beam particles, that block can fall into your feet. Then you need to wear safety goggles to protect you against the particles getting into your eyes. And also we can talk of clamping the support to prevent the supports from rolling. And also we can say you put on safety boots, so that once the beam breaks, it doesn't fall in your feet, so that it can hurt you. Okay, so another particular question also you'll be seeing in the exam is whereby you are told to criticize data that has been recorded in a table. And in that kind of area, you look at the case scenario where you have inconsistency in the number of decimal places and the significant figures that are recorded. Also look at where check if there's evidence for repeat of data in that case, so that you can be able to analyze, yeah. So check whether there is inconsistency. In this case, you can see the number of decimal places recorded is not consistent. Number of significant figures is also not consistent. There is no evidence for repeat of the data. And then from there, we can be able to say we are fully criticizing the data. What I need to say also here is that these experiments, this paper will always be asking the same kind of questions, but you need to know how to approach each of the questions. If you are new to ProfLearn YouTube channel, consider subscribing, so that anytime I'm going to add more tutorials, anytime I'll be adding pure math videos, you'll be notified. Also, if you have found value from this particular video, consider sharing this video to your friends. Encourage them also to subscribe in a way of supporting ProfLearn. You can also check in the description. I've added a link that takes you to the Patreon page, where you can be able to download these model answers I've written, so that you can be able to review your work properly. All right, so we're told the student concluded that the increase in maximum force was proportional to the mass of the fiber in the beam. Increase was proportional to the mass of the fiber in the beam. Explain how the student could justify this. The student should have calculated the change in maximum force and plot a graph of force against the mass, and then the straight line graph passing through the origin indicates that it's proportional, that the maximum force is proportional to the mass of the fiber. We have question number 3, and in this question number 3, we are told the student investigated how the change in position of the sun in the sky affect the power output of solar panels. We know that if the sun is directly such that the rays are striking the panel incident, we are going to have maximum amount of power. Now we are told that one of the solar cell in the solar panel was connected into a circuit, and the circuit also contains a 10 ohm fixed resistor and an ammeter and a voltmeter as shown there. What is the purpose of a fixed resistor? A fixed resistor, mostly when we are talking about circuit, it limits the maximum amount of current that flows in the circuit, right? So that is also for protective measures to ensure that the wires do not overheat. The investigation is affected by background light. Suggests what the student should do to control the background light. This experiment can be performed inside a dark room or a dark area, or you can be able to cover the apparatus with a box, so that you can be able to prevent the intensity or the external light which will affect the result. Suggest 2 other variables the students should control during the investigation. So one of the investigation, one of the control one of the control variable in this investigation should be the distance between the source and the panel. That distance should be maintained, because whatever that is being done here is variation of the angle to see how it affects. So the distance should be kept constant. The power supply on the bulb or the lamp should be kept constant. The type of lamp also should be maintained constant, right? So that we are not going to affect the distance. The power supply should be kept constant. So you can see suggesting 2 of them. Another particular question will be asked is to complete the table. And something that you need to check when you are completing the table always is that you must give your table and the values in the same number of decimal and significant figures as the rest that were provided. So that is key, that is important for you to put into consideration. There was a question to do with efficiency. Remember, efficiency was power output over power input, and power is current times voltage, what we have already done in this particular part. The student plotted a graph of percentage efficiency against the angle, and we see when I did draw the graph became like that. And we are supposed to determine the maximum percentage efficiency and the corresponding angle. So the maximum percentage efficiency you are going to read at the peak. Yeah, you read the value here, and then you read the corresponding angle down there, and you can see the angle is around 55 and the efficiency is around 29.6. So explain how the student could collect more data to increase the accuracy in her maximum value. So it means because our maximum value is lying between this angle 50, 60, around here, that's where the maximum value is lying, then it means the student could have done small increment of the angles so that he can be able to obtain the accurate value. So the moment the student could have reached these values here around 50 and 60, around there, because that's where the maximum lies, could have done very small increments so that we can be able to measure the current and the voltage, and then use them to calculate the power and efficiency so that we can be able to get the accurate result. So that's why I take measurements for current and voltage for small increment for angles between 55 and 60, where around where the peak is. You do small increment, and in that way we can now get current and voltage and use it now to calculate the power, and then use it to work out the efficiency so that our result could be accurate. We are also told in part D, the student only remove the lamp vertically in our investigation during the day. The sun moves vertically and horizontally across the sky. State the direction in which light should be incident. That's at 90 degrees. That's when it will be incident and it will give maximum input. Explain how this could increase. So we are told that the solar panel now is now mounted on a motorized stand. A motorized stand, it means it can be able to rotate and follow the sun. Yeah, so it has a motor, so it can be able to rotate as the sun moves, it also moves. So we can say that the motorized stand enables the solar panel to move and face the sun as the sun moves across the sky, and this ensures that the light is always incident at 90 degrees to the panel. Hence the solar panel generates maximum power, which is going to increase the amount of energy that is supplied throughout the day. I believe that's okay up to that point. Now we are going to look at the last question, question 4. We told a student you'd use the source of ultrasound to create a standing wave in a narrow container of liquids. The standing wave created layer of increased intensity. This caused the liquid to act like a diffraction grating. the student directed a beam of light from the laser through the container, and this produced a diffraction pattern as shown on the screen. So something I need to mention here is that we have the central maximum, and we have the first order. So how is the first order formed? And remember, first order is the region where the bright fringe is formed. Okay, so in a bright fringe is formed due to superposition. A wave from one over the slit undergoes interfere with another wave. So here we are having two waves which are in phase interfering at that point, and the constructive interference taking place. Then from there we shall have now a bright spot at that given point. So this wave will travel to this point, and when the two waves interfere constructively, a bright spot is formed like at that given point. But this question is not asking that. It's just testing the practical skills, so which means that we can now complete the data, and you can be able to find sign of the angle, you can be able to fill in, and then we need to process the data so that we can be able to use them to draw the graph. I've decided to multiply this value. If you just divide by you take the decimal point 2 steps forward so that we can have 0.98. Then if you multiply by 10 to the power -3, it will take you back to this. So processing the data, that's what is being mentioned at this given point. Now from there we can be able to plot a graph. What I need to say, whenever you are plotting a graph, ensure that you label the axis, and also ensure that your graph covers about 3/4 of the graph paper that is provided. So this is the graph that we were expected to have in that particular question, and the student derived the following formula. We are told the formula that was used is here. Explain how the graph of f against sine theta can be used. A graph of f against sine theta can be used. So let me just mention something on that. So if we rearrange the graph here, the formula we're going to have, v over lambda, is going to be our gradient. So because this graph that we are having at this equation that we are having at this point, because we want to have a f being a graph of f is equals to v over lambda sine theta. So if you plot a graph of f against sine theta, then it means we are going to have this part that is here as the gradient, so that we can be able to say now this part represents the gradient. Explain how this can be used to determine v. So from the graph we need to calculate the gradient. Once you have the gradient, you can determine the speed using the formula v is equals to gradient times lambda. Because if we have said that v over lambda is gradient, then if we have the gradient to get v, we shall say v is equals to m times lambda. So that is basically what you are supposed to do. To determine the value of v using your graph, remember now we have already shown, explained what you are supposed to do. There is a gradient. I use my graph to work out the gradient, and the gradient I got is 2.25 times 10 to the power 9, and then from there I can be able to find v as the gradient and the wavelength that was provided. What you need to remember is that the wavelength was in nanometers, so you have to multiply by 10 to the power -9. So basically that is what you are supposed to do in that case. And The last question was the student estimated the percentage uncertainty of the value of V to be 5%. Deduce whether the liquid in the container, which liquid was in the container. So using the percentage uncertainty there, we can be able to get the range where the velocity lie. Then once we have our range here, we can be able to check which of the liquid that we have lies within that range. And in that case, I realized that the liquid that lied here is castor oil. Castor oil is within this range. Let's go and check on the table castor oil. What's the velocity of castor oil? Castor is 1474. And you can see it's between 1489 and 1536. So the only liquid is castor. So that's why you need to work it out. If you got value from this particular video, consider subscribing so that anytime I'm going to do more tutorials, you'll be notified. You can also share this video to your friends who can also benefit. See you in the next tutorial.